Welcome back to Around the World in 80 Telescopes, a live 24-hour webcast that is part of 100 Hours of Astronomy project for the International Year of Astronomy. You're joining us at the European Southern Observatory headquarters near Munich in Germany as we visit some of the most advanced telescopes both on and off the planet. We're now going somewhere a little different, all the way to Antarctica to visit the Concordia station. But before we join them live, let's find out about them in this video.
Benvenuti a Concordia.
The Franco-Italian Concordia station, which was completed in 2004, is built in the heart of the Antarctic plateau, on the Dome C site, at an altitude of 3,233 meters, over 3,200 meters of which is the ice layer. It's a unique location, entirely devoted to science.
Les astronomes ont toujours cherché à s'isoler de la civilisation, à s'éloigner des lumières ambiantes et à chercher des altitudes les plus élevées possibles pour avoir l'air transparent et sans pollution lumineuse. Alors nous en sommes encore au stade de la qualification du site. On a des évidences. Il fait nuit pendant plusieurs mois, donc on peut faire des mesures de très longue durée la nuit. Il fait jour pendant plusieurs mois, on peut donc faire des mesures de très longue durée le jour. Il fait très froid, on est donc certain que l'astronomie infrarouge sera extrêmement bien développée ici. Mais il y a un certain nombre de choses plus détaillées à qualifier. La turbulence de l'air, la statistique de nuages, la statistique de ciel clair, la statistique de vent qui va gêner les grands instruments. Donc depuis quelques années, on a installé toute une batterie de petits instruments qui font la qualification météorologique et astronomique du site.
Estivale. Hop. Et voilà, donc là j'ai un magnifique fond de ciel avec l'étoile qui est un petit peu vers le haut, mais ça va aller quand même. Là on remet le masque. Donc nous, notre laboratoire, sa marque de fabrique, c'est un peu la mesure de la turbulence. Donc c'est pour ça qu'on avait proposé à l'IPEV il y a 7 ans maintenant, il y a 8 ans, de venir mesurer faire ce qu'on appelle du site testing, donc mesurer la météo, mesurer la diffusion, c'est-à-dire le fait que le ciel est plus ou moins transparent, plus ou moins blanc. Donc ça fait maintenant 5 ans qu'on vient régulièrement sur le site avec la première année 1 télescope, la deuxième année 2 télescopes. On est monté en puissance peu à peu et on est à l'aube du 4e hivernage maintenant. C'est ça, du 4e hivernage, oui, moi j'ai fait le 2e. Et donc on commence à avoir une bonne idée, une bonne photographie de ce qui se passe, de la manière dont l'atmosphère se comporte au-dessus du site de Dome C. Par exemple, on s'est aperçu qu'en hiver, à cause du fait que la neige est très froide, la température en hiver c'est moins 70, moins 75, donc la neige est vraiment très froide, il y a un gradient de température très fort au niveau du sol qui génère une couche de turbulence qui fait à peu près 30 mètres de haut. Au-dessus de cette couche, on est 2 fois mieux que le meilleur site du monde. Donc on fait maintenant le tour des colloques en brandissant ces résultats et en essayant de convaincre les organismes de financer des grands projets, des grands observatoires. On pense que c'est un des meilleurs sites du monde, un site où l'astronomie du XXIe siècle devra se faire.
Observing the nearest star, our own sun, is a priority for the astronomers.
Les observatoires solaires aujourd'hui se développent toujours dans les sites de haute montagne. où la stabilité de l'air est rarement très bonne. Ici, on peut bénéficier à la fois pendant l'été d'un ciel de transparence exceptionnelle, de diffusion quasiment nulle et de stabilité en plus très grande qui permet de faire de l'imagerie sur la surface du Soleil très fine, ce qui est très rare ailleurs que dans l'espace. Il n'y a plus qu'à le pointer sur le Soleil et puis on verra bien. Et c'est assez essoufflant de monter sur ces escaliers à chaque fois.
C'est quand même un sacré site astronomique.
Oui, on n'a pas eu de chance là depuis une semaine qu'on est ici, un peu plus d'une semaine. Le ciel n'a pas été vraiment aussi favorable que ce qu'on a l'habitude de voir, mais c'est en train de venir. Le ciel commence à être bien bleu. Il ne l'est pas encore parfaitement à l'horizon. Si je mets mon doigt devant le soleil, on ne montre pas un ciel coronal. Mais ça va venir, demain il fera beau.
We're going to go to Concordia, first in Nice, France. Hello, are you there?
Yes, I'm there. I am Eric Fossa at Nice and comfortably at Nice on the French Riviera, but we are speaking with Concordia, which is not so warm.
And tell us what you do, Eric, at the observatory.
Well, I am at Nice, so what I do is quite comfortable. I'm in fact leading the campaign of site qualification. The Concordia is mostly a future observatory. It's not really yet an active observatory in the sense of doing high-level astronomy. We are now mostly qualifying the quality of the site. And these people you will see now at Concordia, they are doing the hard part of the job, moving outside with temperature of minus 65, 70, 75, and handling telescopes to measure the quality of the turbulence, the quality of the sky in general, the transparency in visible light, infrared light, and more.
So we're going from one extreme environment. We just went to Paranal in Chile, and now we're going to another extreme environment in a different way. So tell us more about, certainly you've experienced it there, tell us more about what it's like to be an astronomer in the Antarctic.
It's tough. It's tough. You don't have the comfort of Paranal, you don't have the comfort of ISO at Garching, of course, you don't have a lot of comfort in general. You have really to work outside a significant fraction of your time by temperature of minus 70 degrees in winter, and you have to start everything because at the very beginning basically there was nothing. So you have in fact two different activities. One activity is thinking what we will do in 5 years, 10 years, 20 years with this fantastic site, because the sky is indeed absolutely fantastic. And the other activity is to do it, to be on the site and to start testing the telescope in such very cold conditions. At first nothing works, then you have to identify why it does not work and to fix it. And this is what they are doing.
And I imagine when the fixes come in that you can't just run down to the hardware store and make a fix. So what is it like when you have to get supplies and things to the Antarctic?
Well, it's indeed very tough because the station is accessible basically 2.5 months per year. You can go there by mid-November and you have to leave by end of January. And then the guys who stay the rest of the time, they are completely isolated. And if they need something, they will have either to wait for 9 months or to have anticipated and to have a store. And okay, sometimes they have the replacement parts, sometimes they don't. So one of the important parts is to manage the general activity and to anticipate all kinds of problems. And we have been there now for almost 9 years. So the problem have been identified more and more in detail. And they will tell you that they can work, and basically they can fix most problems because we don't have yet very huge instrumentations.
Okay, let's talk again about the future as you were talking before. We saw something about solar observations in the video. Can you talk more about, I know that in the distant future you're thinking of the infrared kilometer array. Can you talk about more of the wishes for the future at Concordia?
Yes, of course. Given the sky specificity, the sky has several specificities, sorry. It's 4 o'clock in the morning, you know. It's very cold. Being very cold is very dry, and being very dry is very transparent, especially in infrared. Then this is one possibility to develop astronomy in infrared. There is basically no greenhouse effect at Concordia. If you go out, you can realize that. And so if there is no greenhouse effect, it means that infrared wavelengths go through. So you can receive the infrared light from the sky, much more than anywhere else. Second point, you have indeed a very quiet sky, very little turbulence. And if you move above the boundary layer where you have the surface snow, which is moving a little bit, the dust of snow, and creating turbulence at the surface level, if you move up by 25 or 30 meters, you have a turbulence quality which is about twice better than Paranal. And this is something, because Paranal is a real reference. So we are anticipating for, I don't know, in 10 years, 15 years, 20 years, to have huge optical interferometer, which will be the next generation after the VLTI. This is long distance perspective. And I would say then you have, of course, solar astronomy. During the day, the sky is totally coronal, and you have the prospect of exploiting the long polar night, which means having some missions like CORO. CORO is a space mission which is observing stars continuously, and at Concordia you can observe stars continuously during several months. So we have basically 4 different directions: exploiting the infrared transparency, exploiting the solar quality of the daytime sky, exploiting the very low turbulence level of the atmosphere, and exploiting the long night of the polar regions.
Okay. And is your area of expertise or interest in one of those 4 that you just described, or are you doing something different, Eric?
Oh, myself, I've been a solar astronomer for mostly all my life. And it just happens that now I'm getting close to the end of my professional life, and I'm not doing personally solar astronomy anymore. My personal activity now is just to chairing the site testing activity. I have become more a meteorologist than an astronomer on the last few years.
Okay. I think we'll switch to Antarctica now, but thank you, Eric, for your time, and wish you the best of luck with the future plans of Concordia.
Thank you very much.
Thank you. And we will be switching to Antarctica now. Stay with us here. Oh, it seems like we have the folks at Concordia Station. Welcome.
Hello, we can hear you.
Hello. Looks like there's 3 of you there. Who wants to introduce everyone? Oh, we might be having some technical problems here with Antarctica, as you might imagine. They have a satellite only certain part of the days available to them. So, oh, maybe they're back now. Can you hear me?
So very bad.
So you're back. I think you can hear me
Hello?
now?
Yes, I can hear you.
Okay. Will you introduce yourself and the two others there and tell us what you do at Concordia?
Tu montes un peu là. Non? Allô, allô?
Hello.
Are you still there?
Yes, we're here, and just wanted you to introduce yourselves and let us know what you are doing at Concordia.
Attends, là, elle m'entend pas. I am also the station leader. I'm here with the two guys working from the astronomy project, who are Cyprien Pouzinc and Denis Peterman.
Okay, thank you for joining us from so far away. Can you tell us what your day-to-day work is there in the Antarctic?
I didn't get you, sorry. Maybe I should do just a quick presentation of Concordia.
Okay.
So in Concordia, so Concordia is a research station, French and Italian. We are here since 5 years now. This is the fifth winter hour. We do, of course, some astronomy, but here at Concordia, we also do a lot of other research. We do some biomedicine for the Europe.
Looks like we might be having some more technical difficulties. Go ahead.
Yes, and like Eric Fossard just told you a few minutes ago, this is an extremely remote place. Since we are alone since 3 months now, with no possibility to get any access to Concordia. We are and the conditions are extremely difficult. Since outside it's for the moment something like minus 65 degrees, and we still have some daylight, but in 1 month it will be the complete darkness for something like 4 months. We are also at a very high altitude, since we are at 3,200 meters, which means difficulty to breathe, etc., etc.
Okay, thank you.
Are you still there?
Yes, we're still here. We have a long delay, so I'm trying to give you time to finish your thoughts. So if you could just tell us a little bit more about what you're doing on your shift right now, or are you off shift, or what will you be doing when you're on shift?
We are always on, so everyone is always working. For the moment today, we just took a few minutes to speak with you, but my astronomers colleagues they have to go outside to work on the telescope, and
we're trying to be live here with Antarctica, so bear with us.
Bon. Hello, hello.
Hello. So you were telling us about your shift. Go ahead.
Yes, I was just telling that we are always on shift here at Concordia, since we are only 12 people. So each person is unique, and we don't have anyone to do our jobs. So basically, we always have to work. We are on shift 7 days a week and all the year. We just had some moment to speak with you, but just after we will have to continue our jobs. My astronomer colleagues have to go outside to work on the telescopes, and for me, station, and that's it, I think.
And can you guys tell us personally what it's like to be working outside in those kind of temperatures and working on the instruments under those conditions?
Bah, c'est pas facile. Qu'est-ce qu'on peut dire? Non, bah, tu traduis.
Oui, je peux traduire.
Que le froid complique tout, que ce soit au niveau de la mécanique comme de l'optique.
The cold complicates everything on the optical side and on the mechanical side also.
Et quand il est nécessaire de régler un instrument à l'extérieur, bah, le moindre réglage qui pourrait se faire en quelques minutes en France, il faut beaucoup plus de temps ici et beaucoup plus de précautions.
And when you have to set an instrument, a telescope, what could take just a few minutes in Europe takes a much longer here at Concordia because of the cold.
Et les grandes amplitudes thermiques, par exemple, font que il est peut-être régulièrement besoin de régler les instruments chaque jour.
And since it is very, very cold, we have to set the instrument almost every day. But we don't do that in Europe. That's it, I think.
Okay. And all of you are looking forward to doing research in the future when the site is complete. What are some specific things that you're anxious to use the instrumentation for?
Je suis sûr que tu es super excité une fois que le site sera bien fini de certaines recherches. Quelles recherches tu voudrais que soit menées ici?
Oh, ben, déjà actuellement, c'est extraordinaire.
It's already extraordinary for the moment, you know.
En fait, il y a une mission actuellement qui est en test et dès l'année prochaine, elle devrait être en place. C'est une mission qui devrait partir à la découverte d'exoplanètes, de planètes tournant autour d'autres étoiles, et ce qui est déjà assez finalement passionnant de participer à une telle mission.
What is very exciting is a mission a project that began this year, but which will be fully operational next year about the research of the exoplanets, and that's one of the things that would be wonderful next year.
Puis toujours lié à la découverte d'exoplanètes. Actuellement, en fait, la lumière cendrée de la Lune, donc le reflet de la lumière de la Terre, qui permettra dans le futur également d'étudier.
And there's also a project about the lumière cendrée of the Moon, which will also help to find some exoplanets, which is very exciting for the astronomers.
Okay, great.
And for the mankind.
We have a question from our audience, if you can answer that. It's from Peter from Austria, and he asks, which countries support the Concordia station?
Could you repeat the question, please?
Yes. The question is, which countries support the Concordia station?
Yes, it's a binational station. We are French and Italian.
Okay. We have another question actually from the audience, and this has to do with something you were speaking of earlier, that soon it will be 24 hours of darkness for you. And the question from the audience member is, how do you deal with constant darkness and the isolation of Antarctica?
That's very difficult, but also that's why we came here. For the complete darkness, it will be for 4 months. And what we will have to try to help us, that we will put some light which will be enriched in the blue spectrum to be nearest the sunlight. And for the isolation, we only have the video conference and the phone calls and the emails to try to reach with our families. It's difficult, but that's one of the points being here.
Okay. Well, we thank you for taking time out of your shift, and we'll let you get back to work. And we've really enjoyed having you from this long distance, and we appreciate your time. So thanks for joining us.
Thank you.
Thank you. Good night. You're watching Around the World in 80 Telescopes. Stay with us for the next stop on our world tour.